Yeah, last time we were looking at constants, iota, memory addresses, and pointers. And now we're jumping into remainders, loops, range, switch statements, and conditionals. Does anybody have any questions? You guys ready to take a look at some new stuff? So remainder, this is sometimes called modulus in other languages, but in Go, I like the fact that they sort of just try to be as precise as possible with their diction. They try to choose things which are easy to understand. They try not to make things complex. Right? So modulus, oh, that sounds a little bit complex, but it's remainder. So why not just call it remainder? So in Go, they call it the remainder. And you find the remainder with the percent sign. And I'll just make this a little bit bigger for you all. And so that would look something like this as soon as that loads. X is equal to 101. Remainder, what's the remainder I get when I divide it by 3? And so 101 divided by 3 will have a remainder of 2. And you can see that there in the terminal output that the remainder is 2. So a little exercise for you, which you'll be able to do as homework, is just to write a program that allows the user to enter two numbers and displays the remainder when one number is divided by the other. Right? So you'll use create a variable var. You could do like var x y int, and or var x and var y int, and then displays the remainder when one. So then you want to get user input. So then format print, not print line, because we don't want a new line. Format print, please enter a number, and then that's in quotes, and then format scan, and put in ampersand x, right, your first variable, and then so that kind of a thing, and then another print line, enter a second number, and then format scan ampersand y, and then format print x per percent sign y, and that'll give you the remainder. So now we can talk about loops. And so here's a basic loop, no parentheses around it. Again, just going for as little extraneous crap as possible, keeping things lean and clean. And it's just, so the way you read that is you have a, incrementer, or you have a variable I that's kind of running the loop. And I is set equal to 0. So that first part is called the initializer. You're initializing a variable. And I is only going to have a scope. The scope of I will be just this loop. And so you initialize it. That first part right here is called the init, the initializer. And then this is called the condition. So it's just some check. And so while I is still less than or equal to 100, it'll keep looping. And then when I becomes 101, it's more than 100. It's no longer equal to 100. It'll be like, wait, this is no longer true, and it'll step out of the loop. And then every time, this is called the post, every time after the loop, it will do something. So it says I is equal to 0. Is 0 less than or equal to 100? Yes. Okay, I'm going to print I. And now I'm going to go post, add 1 to I. All right, so then I becomes 1. Is 1 less than or equal to 100? Yes, that's true. And so I'm going to print 1, and then come back up here and add 1 to I, and that's 2. It's 2, and does that, just keeps doing that. Right? And so here's from the from effective Go. And you can see here for init condition post. Right? And so that's pretty much what I just said. You could also just do for condition. And so you could say, hey, while this condition is true, then loop. And so you could then make the condition untrue. Right? So whatever your test for a quality is, you could have some sort of a statement in the loop where something happens and it changes the value of some check, which is the condition, and then you step out of the loop. Or you have just a infinite loop, and that will go until you use some statement like maybe break, right? Like leave the loop. So if this happens, you could have an if statement inside the braces. If this happens, break out of the loop, and you just use the keyword break. Or maybe you just want it to run forever until you manually shut it down. So this is like the C programming language.
Yeah, but are those?
Huh?
That's not Go up there.
This is all Go, in the red, yeah. And it's just saying, hey, this is like, because Go is really rooted in C. And so this is like this, This is like a while loop in C, but in Go we call it for. So they got rid of the while word. Again, why do we need it? You know, and so it's just that's the same thing. It just while this is true, it's going to keep looping. Stay up all night to get lucky. Stay up all night changing diapers, then stay up even later into the night doing your work. Short declarations make it easy to declare the index variable right in the loop. So the index variable is declared. The scope of I will only be this loop. So we just covered that. And then here's that same design pattern, right, with the for key value equals range. I'm not sure if we've seen this already, but this is a really important sort of design pattern to pay attention to in Go and just sort of commit to memory. So anytime you have some collection of things, right, like a slice, which is a list, or a map, when you have a collection of data and you want to loop over it, you could use this range statement. And what it'll do is, like, here's a map, and we're going to learn about maps in a minute. And maps have a collection of data. And so what it does is it'll loop over each piece of data in the map. And you could have a variable key and a variable value. So the key would be like, you know, whatever the key is in the data collection you're looping over. And so and then the value is whatever the value is. And so a range works on these types: a slice or array, a string, a map, and a channel. So I actually saw a really cool example, or I put a cool example together. I'm not sure if I saw it somewhere. And I put it under types and Rune. And this, I just put this in last night. And so let me launch my terminal. And I'm not using a range here, but it might be interesting to try it. So cd documents, go, source, GitHub, goes to 11, and Golang training, and then 16 types, and 07 UTF-8, and go run main. Oops. Let the power begin. Off to the races. And so what this does is here's a loop, and we're going to loop 1,000 times. And each time through, we're going to print what is the value of I, right? So 0, 1, 2, 3, 4. And then we're going to take I, and we're going to, is this, we haven't learned assertion yet. No, we haven't, right? Assertion? No, we didn't talk about that. So this is casting I to a string. So we took a number and we cast it to string. And we learned about runes, that a rune is just another way of saying basically car. And if we look at Golang spec, and let's check out that and see what it says about runes and see if this is where we learned about runes, right? So it tells us a little bit about runes, but I think the main thing I'm looking for are numeric types. And right here, a rune is an alias for int32, which is just a number. And so we have a bunch of numbers. And then if a rune is a character, can I cast a character like, you know, single quotes? Can I cast that to string? And yeah, you could do that sort of a cast. And so I'm casting this to a string. And what that does is it prints out all of the UTF-8 characters, right? So this is basically ASCII because the beginning of UTF-8 is ASCII. And so here is like capital S is 83. You know, it's the coding scheme. And I could come down here and look at these other numbers. It goes a long ways. I did it to like 5,000 at home. But here are all these crazy letters and symbols from other languages. So I could see, hey, what is the rune, the int32, the rune for this symbol? It's kind of cool. And so we could try this maybe with a range loop for, and we know key value, colon equals, and we're going to range. And what do we range over though, right? Like I don't have, you know, I need to have some sort of a thing to range over strings, or I don't know. So that's where I just died on the range. I just died on the range, right? Because a range will loop over present slice array string map channel. So I need to put in like whatever numbers into some sort of slice or array or something like that. And I don't have that.
Does the word Rune define anything like that?
Now Rune is just kind of like int, right? Or float 64. Rune is int 32, and it's a type which you could use to say, look, I know that in ASCII UTF-8 these are ultimately just numbers that represent symbols, and so I'm storing a number there, right? But you know, if it's because I want the symbol, I call it a rune. So here, let's take a look. See a little bit of a quizzical look on your face.
Well, I'm just
So let's say that I have var. Let's bring this into trial, actually. Let's come down here to trial. Trial. Well, this is kind of interesting. Well, let's keep it simple, though. So,
can you make an array of
car.
from 1 to
Huh?
array of numbers from 0 to whatever the last 32 is?
Yeah. Yeah.
And then just do it that way?
Yeah, you probably could. But you have to have a loop to do that easily. So here's the car, and then if we do format.println and look at reflect type of, which is another way to find the type, and do this, and then type is N32 there. So I'm right there. I was just, said this, car is that. But I think I could have done this too. Car 2 Rune is equal to T or whatever, X, F there. Or I'm just choosing all these different. And then they both come out as N32, even though I gave this a type of Rune. That's just a, what do they call it in the documentation?
Shouldn't the capitals and the lowercase be different numbers?
Yeah, they'd be different numbers, but that was just showing me what the type is.
Oh.
So it's an N32. So here it's an alias for N32. All right, so
I'm sorry, I don't get that because you find it as a character.
as a rune, yeah. So Rune is, and thanks for asking, and Rune is just an alias. So you could use that, so when you're reading the code, hey, this is what I'm putting there, but really what's getting stored there is an N32. Just like we could refer to bytes, but really that's a UNT8 if we look for the type. Just an alias.
So it'll store
Just like, I don't know, do you have a nick? Riri. Riri's an alias, right?
So it stores the number, but when it returns the room, the character?
Yeah, so we could play with that. And, so here is, so if I do this, format.println, and just put print car, what's that give us? And this is a 83.
What gives the number?
Yeah, and so now we could play around with conversion, which is also known as casting in a lot of languages. But again, this is Go trying to be really precise and also simple about calling things. Because casting, like, which is a better description? Should we call it? What was the one we were just looking at? The example we were just looking at, where they called it
Modulus and remainder.
Modulus versus remainder. Thank you. That's what I was trying to remember. So, hey, let's call it remainder. It's a remainder. It's what you call it in math. When you're in school, it's just called a remainder. And here, gosh, what was the example I was just going to cast? Oh, yeah, casting versus conversion. Hey, we're just converting from one type to another, right? Casting, not quite the same, as being as precise. So anyhow, so that prints out 83. Well, could we convert that to a rune? What happens if we do that? Right, N32 to a rune. Will that change anything? And so let's run this again. 83, and so it didn't throw an error, right? And then let's try, putting that to a string. And run this again. String car. Looks like it didn't print anything. S, there it is. Gave me S.
So, I'm sorry, I feel a little slow here.
No.
You defined it as a character, so it's a string. In the first char equal.
Oh, this I could have called this,
I know, but it's still a string because it's got quotes, right?
It's a rune because it's single quotes.
Single quote.
Single quotes.
That's where I was getting.
Yeah.
Okay.
So.
Sorry, I forgot. I've been taking JavaScript too, so.
Yeah, I know, dude. Languages.
Okay.
That is a
I'm
difference.
like, wait a minute, that's just a string. I don't understand how you're getting a return of a int.
Yeah, no, that's the difference between this and
Okay.
JavaScript.
That's right. So a rune, an alias for an int, 32.
Yep.
Got it.
Cool.
Good question.
Yeah, I'm like, either I'm slow, which could be true, or I'm not getting it, and that could be true.
I think programming brings us up against that feeling. At least it does for me too. Like, I must just be slow, But it is, just to give it credence, it is learning a whole new language. And not only that, there's a whole new way of thinking about stuff. And so if you have some exposure, great. But then even if you're coming to the new language and you already know programming, you got to figure out how does this language work and what's the syntax. So we're looking at loops. Scope of I is only in that loop. And we saw this key value. So let's loop over a string with range. It says we could use range to loop over a string, just out of curiosity. So I'm going to call this my phrase, and what's a good phrase? What is a good phrase? And now let's do a range for key value. Huh?
You want double quotes on the end of it?
Oh, I do. Thank you.
Only because it's red.
Yeah, that's a very good sign usually. I don't know how I can continue going sometimes when it's that red, as if nothing's wrong. For key value range, my phrase. And then we could just format print line, and let's do key, and then a little bit of a divider, and value. And let's just see what that gives us. Imported and not used, reflect. Easy one to fix, right? I can't import something and not use it. That's an error. Just like if I define a variable and don't use it, that's an error. So it gave me, there's the key, just all those numbers on the left. That's just 0, 1, 2, 3, 4 going up, right, each time through the loop. And then it gave me all the values. Well, now we know, hey, we could take that value and we could also do this. And we could say, that's a string. Make that value a string. So some of them are just empty spaces,
Right.
because they're spaces.
That's good.
What is a good phrase?
That's a good example.
Right.
So
Cool.
the key in this case is looking at the value of my phrase and figuring out the length.
Key is just each time through the loop. So it's, yeah.
So what's setting the looping number then? 'Cause
So range just looks at, okay, what
Oh,
object I
range.
need to
That's right.
loop over, and it would be the same as length, my phrase, for how many times it goes through the loop. It goes through for each item in there. And when you give it a string, it goes over each character and gives you back as the value the rune, or the int32.
I was stuck on the key and the value and just didn't link. I've blank on
Yeah.
the range. I'm like, oh yeah, it's the range.
Yeah.
Range is what it is.
So range gets the range of the myPhrase object.
It's
Yeah, the myPhrase variable.
Yeah.
It's the
Okay.
entire object, all,
So
everything.
it's
Yeah.
like array, there's a array link we think of, right?
Yeah.
In JavaScript.
Yeah. Yep.
Same concept,
Yeah.
except it's
Yeah.
range.
And I could have also done it like this. And so the first part is the init. So I'm going to initialize a variable. And then is the test. And so I want to do this while I is less than. Or do I include an equal? We'll think about this for a second. Right? So we're going to do it while it's that.
Oh, okay.
And then we're going to do I plus plus. And now I could just bring in this.
Except you don't,
That
yeah, you
probably-
didn't change your variables, right?
Yeah, and I need to make these I. So I, and then here I need my phrase, and I need to access, like as an index, like give me, the 0 position, give me the 1 position, give me the 2 position, the 3 position. And then here I could take that position, and I could turn it back into, so that's the equivalent of value. And so let's comment that out.
So I don't think you need the equals then.
Let's see.
That's going to be one too many.
Kabam! One too many? Maybe. So let's see what Eric gave me. And
Out of range.
and so runtime error, index out of range. So it got all the way through the end, and then it tried to do one more. So I think you're actually absolutely right, because it's a 0 base index, and I just went one more. And off. That's a off by 1 error. And there we go. Nice catch, Bob.
Very nice. It's good to see it both ways.
Yeah. So that's the length thing.
But range seems so much cleaner and concise, which
Easier.
is what I like.
Yeah. So we use it on slices or arrays or strings, and strings gives us the Rune, right? The code point to UTF-8 character. And if that's a little bit foreign to you, you could kind of like take a look, like, the first part of UTF-8 is ASCII. And so you could say, what's an ASCII table? And you can see the images for an ASCII table here. And that's it.
So with the 4, you can start in the middle. You don't have to start at the beginning. Can you do that with the range? Or does the range just do
Yeah, just the whole thing, beginning to end. Otherwise, go to 4. So here's an ASCII table, and it's basically an encoding table. And so computers, here's my 4-minute description of how many people understand switches when I talk about computers, the role switches play. Let me see your hands. How many don't?
I'm not sure what you're
Okay, cool. So computers run on electricity. Electricity can be on or off. And we could start to encode and convey messages depending upon whether something's on or off. Think about a porch light on Halloween. If that circuit, that light, is on, it means come trick or treat. And if it's off, it means go away, don't come trick or treat at this house. So with a switch, right, and with the state of that switch, on or off, we're able to encode and convey a meaning. And so that's a coding scheme. And so that's how computers work, but there's billions of those circuits or switches. And we could say, okay, instead of one porch light, we have 2 porch lights. Well, now we can encode, with 1 porch light, we can encode 2 messages, on or off, right? On means this, come trick or treat, off means go away. With 2 porch lights, we could encode 4 messages. They both could be on, they both could be off. One could be on and the other off, or vice versa, in which one's on or off. And that can mean 4 different things. So if I'm Leave It to Beaver and I want to convey a message to my buddy across the street, I don't know, Haskell, is that his name or something like that? Whatever. Right? I could have flashlights, 2 flashlights, and I could convey 2 messages depending upon the order, of how those are on or off. And so then we just add more circuits or switches. If we add 8, that gives us 255 possible encodings. ASCII uses 8, it's a byte, and it only has 127 because one of the bytes is used for something else. I'm not sure what. But here's the first 127. And so if you have the letter S, that's in decimal 83. Well, how do you transfer 83 to on or off? Well, let's come over here and see if we can't do that. And so here we're printing all that stuff out, and that gave us this. Can we see that in binary somehow? right? Is there some way to see that in binary? And let me just think about this. So instead of print line, I'm going to do print f, and then I'm going to have a string here. And the first thing I will print is and if I look at my format package, godoc.org, and then I know just /format because that's the package I want. It'll bring up the documentation, and we have these printing verbs, these formatting verbs, and here's the general ones. And we learned that %v is just the default format for %v. So for bool, it's %t, right? And for string, it's %s, And so if I want to print this value right there, I can just do %v, and since that's a string, it'll hopefully give me %s. So let's just pass that in here and see what that does. And so it's just the index, and this is going to reference. I also want, I guess, just the index. We'll pass in the index too. So we'll do %v dash %v and see how that. And since it looks at it and it says, oh, hopefully it'll look at it and say, you're an int, so I'll use %d, and you're a string, so I'll use %s. And so let's run that. That's trippy. It's not what I was expecting. So let's try this. Let's try %d and %s. And hey, whoa, what happened? What happens? I need to restart my terminal. CD. Yeah, thanks. I do need that. Documents go and source GitHub goes to 11. Golang training, and I am in 99. All right. So and at the end, let's do a new line character so we get things each line. So here it gave me my index, that's good. But here it gave me %s uint8 87. So uint8, I don't know, is there a formatting verb for uint8? Uint8 %d. And I was trying to, so it wants that again. Let's try that. Let's see what happens. That's interesting. So there's the index. And then there is a number. And how can we get that to a string? Printf string. So I'm just going to look here for a string. Uninterpreted bytes of the string or slice. Double quoted string safely escape. String and slice of bytes. So maybe %q. All right, so if not %q, then %s. Yeah. Yeah, but I want to see. I want to.
That letter that you were asking about was 101000.
Oh, it's missing an argument. That's what it is. So I need to add this again. There we go. So now let's see what happens. So then it gave me. So that is the q, which gave me double quoted string. What about just s? Let's see what s does. So I like q better. And that's giving me that. And now how do I turn that into binary? Let's come over here. And floating point, base 10, base 2, b, %b, base 2. So let's add %b, that's base 2, and we need to add what we're passing in. And new line, thank you. Mini brains are better than one. There's the binary, right? And so, if we look at ASCII, and so let's just look at the capital W. In decimal, that's 87. In decimal, that's 87. So ASCII. And capital W is decimal 87. Isn't that cool? And so how does that translate to binary? And I have this really cool thing I did for my my 15 class just the other day, right here. And so how, 87, if 87 in decimal, if you remember how we learned decimal, so don't pay attention to this for a minute. But if you remember how we learned decimal up at the top, we have the ones place, the tens place, the hundreds place, the thousands place. So, to say, hey, if I have $87, I have 8 $10 bills and 1 $7 bill, right? And the way you figure out the ones place, the tens place, the hundreds place, the thousands place is it's 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, it's base 10, right? And anything to the power of 0 is the ones, right? Anything to the power of 0 is 1. And so that could be 0 through 9, and I could have 0 through 9 $10 bills and 0 through 9 $100 bills. So that's how the decimal numbering system works. I don't know if this was ever explained to you, the decimal number system in this way back in elementary school. Does anybody remember that from elementary school a little bit? So then I just say, okay, well, instead of base 10, I change the 10 to 2s, right? And I literally have to write this out, like, oh, how does it go again? And then I just figure out what these is. I figure out what these is. I figure out what these are, and that's anything to the power of 0 is 1s. 2 to the power of 1 is 2s. 2 to the power of 2 is 4s. 2 to the power of 3 is 8s. And so those are my places, right? Like, and just like in decimal, I have 1s, 10s, hundreds, thousands. In binary, I have 1s, 2s, 4s, 8s, 16s. And then if I need to figure out some number, I just need to figure out how many of those bills I need, right? So if I need to figure out the number 14, well, 14, I can't have a 16 because that's more than 14. But I'm going to need one $8 bill, one $4 bill, so that's 12, and one $2 bill. And that's, did I say 14? Mm-hmm. Yeah, so 8 plus 4 plus 2, right, is 12, 14. So that's how I'd write 14 in binary. And so when I look at 87, well, I don't need a 128, that's too many, but I'll take a 64. And 64 and 87, I need another 23. And so I can't have a 32, that'd be too many, but I'll take a 16. And 16 to 23, I need another 7. And so I can't have an 8, but I could take a 4, I could take a 2, and I could take a 1, and that's 7. So now I have 1, 2, plus 2 is 3, right? So this is my running total here, okay? I have 1, plus 2 is 3, plus 4 is 7, plus 0, 8 is 7, plus 116 is 23, plus 132, 0 32s is 23, plus 164 is 23, plus 6, 20 plus 60 is 80, 4 plus 3 is 7, 87. So in decimal I write that, or in binary I write that, and let's compare that to this. So what were we doing that for? 87 is 1 0 1 0 1 0 1 0 1 1 1. Awesome! And so that's just a coding scheme, man. It goes all the way back to the Halloween porch. The light's either on or the light's off. And you've encoded this arrangement of circuits, zeros and ones, right? It's on, it's a 0. It's off, it's a 1. It's off, it's a 0. And it's on, it's a 1. Right? You've encoded this arrangement. It's like literally at the circuit level, there's somewhere in there are little light switches, but they're not lights, they're circuits, right? Little, switches, circuits that are on and off. And the computer's looking, you see, are you on and off? This arrangement's on in this order of on and off, and I have this other coding scheme, and in that arrangement of on and off, I show the letter W, capital W. That's all it is. And here's something about binary that not everybody knows. In symbology, right? We have a 1 and we have a 0, on and off. That's the on-off switch. It's a 1 and it's a 0. I know, isn't that awesome? It's like the power symbol goes all the way back to the fact that these devices run on electricity, and electricity can be on or off. And that's a 1 and a 0. I don't know, I think that's all cool. When I kind of put all that together, I was like, whoa, wow, check it out. Look at how it all works. So we kind of went on a little bit of a tangent, but I think it's a good tangent. Whoops, I don't want that. I want this. How many people learned something new so far?
I learned that thing about the power symbol.
Power symbol. You knew the rest of that? Cool. Nothing new yet? Right on. So you can also just do key and not ask for the value. So I just want the key. And if you want just the value, you got to throw away key. Use the blank identifier. We already looked at that, did we not? That's familiar. So I'm saying, I know that I'm supposed to get a key here. I'm not going to use it. I just want the value. So this is kind of trippy code. When I first saw this, I was like, what? It took me a second to digest it. And then kind of doing this mental notation and recognizing, oh, that's the init. That's the condition. That's the post. OK, it's a loop. And then doing this really kind of helped me see it. I is being assigned to 0. J is being assigned to length of a minus 1. There's my condition. And then in the post, I is having 1 added to it, and J is having 1 subtracted from it. And then just a little reminder, we kind of looked at multiple assignment when we were first looking at variables. So that's all that's being used, and that previous one was multiple assignment, but it made it look kind of confusing, you know? I think A, you know, is we're reversing something, so it does look like it's like a slice or an array. And when I say a slice or array, we're going to look at those, but a slice is basically built on top of an array, but it can dynamically change in size. Yeah. So we'll have another exercise where we write a program that loops from 1 to 1,000, printing even numbers. So you've been listening to me talk for quite a bit. Let's do a little hands-on. Let's do this one.
Prints all even numbers from 1 to 1,000.
Yeah. Start out just print all numbers from 1 to 1,000, then figure out how do I get it just to print even.
Oh, I already got it.
You got it.